So hi students, today we are into the third lecture of this crash course. So today I am going to take unit and dimensions chapter. That is also one of the important chapters, and definitely in NEET they also ask these questions, and JEE mains also they ask from this chapter. So this chapter is the basic and some dimension kind of things, that dimension of force, dimension of energy, these kind of questions they ask normally. So without wasting time, we are going to start the chapter. Let's start. So unit and dimension. See, first thing that we have fundamental quantities. Fundamental quantities. So we have total 7 fundamental quantities. Okay. So we have 7 fundamental quantities. What are they? These are mass, length, time, temperature, current, amount of substance, and seventh, luminous intensity. Now these are the 7 fundamental quantities. What are fundamental quantities? The quantities which do not require other quantities to define them. For example, if I take another quantity, another kind of quantity which we call derived quantity, there is another kind of quantity which is called derived quantity. Okay, for just one example I am going to take area. So area is derived from length. What is area? Length into breadth. So breadth is also a form of length. So area is based on length. Means if there was no length, there we won't be able to define area. Correct? So this is the difference between fundamental quantity and derived quantity. See, this mass, length, time, temperature, current, amount of substance, luminous intensity, these 7 are the fundamental quantities. Okay. Again, derived quantity. If they ask what are the derived quantities, so any quantity apart from these 7 will fall under derived quantity, like area, then volume, force. Force is made of mass into acceleration. Means force, if you are finding the formula for force, force depends upon mass which is the fundamental quantity. So derived quantities are based on fundamental quantities. Okay, so we should remember this. Now next point, dimension. So if any quantity, if we can define them in the form of m to the power something, l to the power something, t to the power something, then this we will call the dimension of that quantity. Just one example I am giving. Like for example, force. If they ask what is the dimension of force, they write like this: dimension of force. This is the symbol for the dimension. So force, if they ask the dimension of force, what we have to do? We have to think any formula of force, any formula you can think. Like basic formula, force equals to mass into acceleration. Now my intention is to write this force in MLT form. M for mass, L for length, T for time. Again, I am saying M for mass, L for length, and T for time. Now, how to do? See, force, I have written mass into acceleration. So, mass into acceleration. Now, what is acceleration? Rate of change of velocity. Means how much velocity is changing in how much time. Now, if I want to write this in the form of mLT, so see how we are going to write. For mass, I will write m. Change in velocity. So, change in velocity will have, like, what is the unit of velocity? SI unit of velocity. Meter per second. Meter per second. Meter means length. Meter means length per second, or I will write like this, per second means per second time. So this is change in velocity divided by time. So again one time I will add. So mass into acceleration is the formula for force, and this, if we are writing on the dimension, we are getting this. So finally what we get? M to the power 1, L to the power 1, and T square. So if I put it up, so it will be T to the power minus 2. If any power or any quantity we are shifting from numerator to denominator or denominator to numerator, the power sign gets changed. So this was T square. If I shift up, it will become T minus 2. So this is the dimension of force. This is the dimension of force. mLT minus 2. Now I request all the students to at least remember this. Only one formula you have to remember. Only one dimension you have to remember. That is the dimension of force. Okay, because it is repeatedly used in the exam. They ask dimension of those quantities in which force will be like required. For example, if they ask what is the dimension of work, what is the dimension of work? So what to do? Think of any formula of work. So work, can I write force into displacement? So F dot S, we know this is the work. So this is force into displacement cos theta. The cos theta will have some value like 1 by 2, 1 by root 2. So it has no mass, no length, no time. So basically we can write force multiplied by displacement. Now why I told you that, remember, because force many times come. See here, force, what you will write the dimension? mLT minus 2. This is the dimension of force multiplied by displacement. Multiplied by displacement. So finally we are getting m L square T minus 2. This will be the dimension of work. Correct? So dimension of work will be ml square T minus 2. So you don't remember these formula ml square T minus 2 because we have lot of quantities. N number of quantities. It is not possible to learn all, but force you remember mLT minus 2. Correct? Because it will be used multiple times. Okay. Now suppose someone asks what is the dimension of energy. Now if I ask you what is the SI unit of energy? SI unit of energy. SI unit of energy. This is joule. Now if I ask what is the SI unit of work? This is also joule. So always remember that quantities which are having the same SI unit, the quantities which are having the same SI unit will have the same dimension. So So from here, I can write dimension of energy will be equals to dimension of work, and that is ml square T minus 2. So always remember, if same SI unit, if two quantities are having same unit, they will have the same dimension. Same dimension. This point is important. Okay. Now, see, we have some points to remember that trigonometric functions, some quantities are dimensionless, like trigonometric functions. So I am talking about dimensionless entities. So like all trigonometric functions will be dimensionless. How? See, like if I say sine of any angle theta. Now we know that this theta is what? Theta is angle. Angle is suppose 60 degree. Correct? So this angle is dimensionless. We know that this theta is dimensionless. Correct? How theta is dimensionless? See, how we define theta? Theta basically we define, see, suppose this angle is theta, this length is A, this point is A, this point is B, and the radius is R. Now how we define plane angle theta? Plane angle theta. So it is defined as the ratio of this arc length AB. So this arc length AB by R. Okay. So this arc length AB divided by R. This is how we define theta. Now if you see, this arc length AB will have the dimension of length because it is length only, na? And this radius also will have dimension of what? Length. So finally, if someone asks what is the dimension of theta, so there is no mass, so m to the power 0, L also 1 minus 1, 0, you can cancel, and there is no time, so 0. So dimension of any theta is always 0, m0, l0, t0. Correct. Similarly, we have solid angle also. Solid angle, this is also dimensionless. If someone asks what is the dimension of solid angle, it will be m0, l0, t0. So remember these 2 points. The dimension of plane angle or solid angle, any kind of angle, it will be m0, l0, t0. But if someone asks that do we have unit of angle? Yes, angle unit we study now. Degree, radian. If I ask what is the SI unit of angle, you will say radius, radian. So this theta, this plane angle, if someone asks what is the unit, SI unit, so unit is radian. Similarly, solid angle, phi, suppose I say phi, its unit is steradian. So if someone asks whether solid angle or plane angle, they have unit? Yes. Plane angle unit is called radian and solid angle unit is called steradian. But are they having dimension? No, they are dimensionless. M0, L0, T0. So this I was saying that which quantities are dimensionless? I was talking about dimensionless entities. So what I told, that all trigonometric functions are dimensionless. So you have to understand, like if they are given sine of something, anything, sine of angle theta. So just now we saw that this is also dimensionless. And this whole entity, whatever we are getting sine theta value, because sine theta we will get one value, na? Like 1, 0, 1 by root 2. So this whole quantity will also be dimensionless. Correct. Similarly, log of x. So this x is also dimensionless. And whatever we will get after solving the entire log of x, like log of 10, value is 1. So this is a number, na? It does not have mass, it does not have length, it does not have time. So log of x complete will also be dimensionless. Then exponential function. E to the power x. So this x is also dimensionless, like e to the power square, e to the power cube. So this is a number. So this is also dimensionless. And whatever we are getting the whole thing, that e to the power x, this is also dimensionless because e is also number, 2.71 Euler's number. So a number to the power number will be a number. It does not possess mass, length and temperature. So this will also be dimensionless. Next, any constant numbers, any numbers you see, like 2, 8, pi, these are also dimensionless. Some ratios of same dimension, ratio of two quantities having the same dimension. Like for example, see some ratios I am writing. You have to be careful. Like suppose strain. What is strain? Change in length divided by original length. Stress strain chapter. Change in length divided by original length. If someone asks what is the dimension of strain, so change in length will have the dimension of length, and this length will also have the dimension of length. So like finally L and L will cancel, so there will be no dimension, means M0, L0, T0. So some ratios, not all the ratios, if you say like stress, so stress is force by area. So force is having some different dimension, area is having some different dimension. So overall we will get one dimension. But ratio of two entities having the same dimension will also be dimensionless. So these are the things we have to be careful. These are dimensionless. Correct? For example, let's take one example. Before example, I want to tell one more thing. Law of homogeneity. Law of homogeneity. What it says, like suppose for example I am telling, like I have to add the length of 2 pens. Suppose I have 2 pens. This pen length is 2 meter, for example, and another pen I have that length is 3 meter. So if someone asks what is the total length, so I will write 2 meter plus 3 meter. So finally we will get 5 meter. So what we can see, then while we are writing this term and this term all are having the same dimension. See, dimension of length, dimension of length, dimension of length. So all these things, three terms are having same dimension. Correct? Means you can never do like this now, that 2 meter plus 3 meter square equals to 5 meter. This is wrong. This is length, this is area. How you can add length and area? So we can always add or subtract two quantities having the same dimension. Correct? We can always add or subtract two quantities having the same dimension. And the overall result we will get, that will also have the same dimension. Means, for example, if there is any formula like x equals to a plus b minus c. So what I am saying, dimension of x will be equals to dimension of a, will be equals to dimension of b, will be equals to dimension of c. Correct? For example, s equals to ut plus half at square. So dimension of s will be equals to dimension of ut, will be equals to dimension of half at square. All these three terms will have the same dimension. You can check also, like dimension of c, dimension of s will be what? Length, s is distance. ut, dimension of ut. So u is what? Speed. Speed means meter per second. SI unit meter per second. So meter per second. Multiplied by time. Time cancel. See, again it is coming L. So both these dimensions are matching. Let's take one example. Like P equals to rho by x plus y into sine to the power z t. This they have given, or sine of, not power, zt. This they have given. They have told that P is pressure, rho is density, T is time. Our duty is to find a dimension of x, find a dimension of y, and find the dimension of z. These three things we have to find. So let's find. See, one thing is sure, that dimension of P and dimension of rho by x will be same, and dimension of this, all these three terms, dimension should be same. Now P is pressure. What will the dimension of pressure? Pressure is any formula you remember. Pressure is what? Force by area. So pressure we can write, in order to determine the dimension of pressure, pressure will be force by area. What is force? I told the dimension mlt minus 2 divided by area. Area will be length square, meter square, length square. So this was the dimension of pressure. So finally, M, L1 minus 2, 1 minus 2 minus 1 and T minus 2. This is the dimension of pressure. Correct? Now, what is the dimension of density? So dimension of pressure I am writing ML minus 1, T minus 2. Now what is the dimension of density? Density is nothing but mass by volume. Mass by volume. Volume is nothing but length into breadth into height. We can write like this now. So mass, this length is also having the dimension of length. Breadth is what? Length only. Height is what? Length only. So L cube means M L to the power minus 3. Now we know that dimension of pressure will be equals to dimension of density divided by X. Correct? So we can write like this. Dimension of pressure was M, L minus 1, T minus 2. Dimension of density M, L minus 3 divided by dimension of X. M cancelled. So dimension of X, I will shift this side. So dimension of X will be equals to, see, L minus 3, this term will come down. This I am shifting this side, this I am shifting this side. So L minus 1, T minus 2. So dimension of X will become, minus 1 will go up. So plus 1, minus 3 plus 1 means minus 2. And T to the minus 2 will go up. So it will become T square. Means finally we can write dimension of X as M to the power 0. There is no mass term. L to the power minus 2. T square. This is the dimension of X. Now, see how to find the dimension of Y. We know that just now I told that the dimension of this entire quantity sine of theta will be dimensionless. Dimensionless. Correct? Means this is dimensionless, and this complete term means involving Y also will have the dimension of pressure, and dimension of pressure is ML minus 1 T minus 2, and this is dimensionless, means Y should have the dimension of pressure. This dimension and this dimension I am saying both should be same. This is dimensionless, so remove it. Dimensionless means this dimension should be this dimension, means dimension of Y should be equals to dimension of pressure, which is equals to M L minus 1 T minus 2. Correct? Because this whole quantity is dimensionless. Now I told one more thing. This theta, this is also dimensionless. Means dimension of Z multiplied by T, this is dimensionless. M0, L0, T0. So if someone asks what is the dimension of Z, so M0, L0, T0, this time will come here. So finally it will become M0, L0, T minus 1. This is how we are finding the dimension. Very easy. Just you have to practice little bit. Correct? Okay. Now see like any quantity, we can write for any quantity, this N into U value is constant. Now what is this N and U? N is number, U is unit. Like for example I am taking so that you better understand. 5 meter. So this 5 is the number and meter is unit. So 5 meter equals to, can I write 500 centimeter? 1 meter 100 centimeter, 5 meter 500 centimeter. So this is the number, this is the unit, and if we change the unit, the number will also be changed. The unit was meter, the number was 5. The unit is centimeter, the number is 500. So this way, like they can ask anything. For example, like we know that density of water is 1000 kg per meter cube. We have to convert in CGS unit, that is gram per centimeter cube. Now, if they ask from SI unit to CGS unit, it is very easy, very easy. See, what we have to do, so density they have given 1000 kg, so 1000 into 1 kg can I write? Per meter cube, means 1 meter into 1 meter into 1 meter. This is the meaning of per meter cube. Now 1000 kg, 1000 into 1 kg, can I write into 1000 gram? 1 kg is what? 1000 gram. 1 meter is 100 centimeter. Again 1 meter is 100 centimeter. Again 1 meter is 100 centimeter. Basics. So here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Which how much it is coming? 1 gram per centimeter cube. 1 gram per centimeter cube. So if they ask what is the number, so you should write 1 gram per centimeter cube. So when we are moving from SI unit to CGS unit, okay, it is very like easy. Just you have to replace like 1000 kg, so 1000 into 1 kg divided by meter cube. Meter cube means 1 meter into 1 meter into 1 meter. Now see, sometimes like little bit difficult question they ask. They change the unit system. It is neither SI unit nor it is CGS unit. There is a new system. Like one example I am taking. There is a new system in which unit of length is taken as 5 meter. Unit of mass is taken as 2 kg and unit of time is taken as 4 seconds. So normally unit of length is what? 1 meter. Unit of time 1 second. Unit of mass 1 kg. But they have changed, they have brought one new system where unit of length is 5 meter, unit of mass is 2 kg, unit of time is 4 seconds. Now they are asking in SI system, in SI unit system, if we have suppose energy, I am writing energy equals to 5 joule. Energy equals to 5 joule. So in this new system, question is, in this new system, what will be numerical value of unit? Numerical value of unit. Now see how to solve this kind of question. When system they completely change, unit of length 5 meter, unit of mass 2 kg, unit of time 4 seconds. if they completely change the system, how to find? See, we know that one thing, that nu is constant. Correct? What we have to do, see the steps, easy steps. You follow the steps, you do all the questions, you will be able to solve. Now, energy, what is the dimension of energy? So, dimension of energy is same, you remember the dimension of work, because same unit. So, dimension of energy, we can write m L square T minus 2. This is the dimension of. So what we can write here in the SI unit system, they have given 5 joule. So you write here in SI unit system it is 5 joule. We have to find what number in the new system. Suppose there is a new system. So what will the numerical value in the new system? Like 5 meter equals to 500 centimeter. So in the new system where unit of length is centimeter, the numerical value is 500. 5 meter equals to 500 centimeter. Similarly here 5 joule equals to how much in this new system? Now this is not CGS system, na? So you have to solve differently. See, mass. So you write mass. See here we have now mass. So you write unit of mass 2 kg. So you write 2 kg. Correct? You write 2 kg. The length square. Length, unit of length is how much? 5 meter. It's square. So 5 meter into 5 meter. This will be length square. Divided by t square. So unit of time is 4 second. So 4 second into 4 second. Now solve how much it is coming. So this 5 get cancelled. This 2 2 ja 4. So we are getting 5 by 4 2 ja 8. 5 by 8. See here. This is 5. This is 2 2 4 ja 8. 5 by 8 kg meter square per second square. This will be the answer. So this is the numerical value 5 by 8. Means 5 joule of SI unit system corresponds to 5 by 8 in the new system. Okay. So this kind of question can be asked. Important question. And many students skip this kind of questions. So like this is important only. Correct. Okay. Next type of question what they give, that they say that time period of pendulum depends upon its length and acceleration due to gravity. We all know that time period depends upon length and acceleration due to gravity. You have to formulate or you have to tell that the dependency of time period upon length and acceleration due to gravity. How it depends? Like time period is directly proportional to L, or time period is directly proportional to L square, or time period is directly proportional to L cube. Similarly, time is directly proportional to G or G square, G cube, like this you have to tell. So in these kind of questions, what we do? We write time period is directly proportional to length. We don't know the power, so I will write A. Again, it depends upon G, so I will write G here. But what power we don't know, so I will write B. Now, this side we have time. Time period means what? Time. So we can write M0. There is no mass, there is no length. Time is there, so t to the power 1 is directly proportional to length to the power A, and G. What is G? G is acceleration due to gravity. G is nothing but acceleration. Acceleration is what? dv by dt. What is dv by dt? Meter per second. Meter per second divided by time means length t to the power minus 2. This will be the dimension of gravity. So dimension of gravity I will write L t to the power minus 2 gravity. This is the dimension of gravity, and to the power b, this to the power b, because gravity to the power b. So here we can write length, here it is a, and here length power is b. So finally we can write length to the power a plus b. Similarly, time, power will be minus 2 into b, minus 2b. Now if I match left hand side and right hand side, what you can see, if I compare these two, here length power should be 0, here length power is coming a plus b, means a plus b should be 0. This is our first equation. Second, time power is 1 and time power is minus 2b, means minus 2b should be equals to 1. Now if minus 2b is equals to 1, so b equals to minus 1 by 2. And if b equals to minus 1 by 2, you put here minus 1 by 2 plus 1 by 2 will be equals to 0. So a is coming out to be plus 1 by 2. Means finally what we can write? Finally we can write time period is directly proportional to length. Length means see L to the power a. So L to the power a we have got 1 by 2. G to the power b. So G to the power b we have got minus 1 by 2. It means time period is equals to some constant. L to the power 1 by 2 means root L, and G to the power minus 1 by 2, G will go down, so power will become 1 by 2. G to the power 1 by 2 means what? Root G. Root G. So finally we can write K under root L by G. This is the time period of simple pendulum. And we know that if you have studied what is K? 2 pi. Time period of pendulum is 2 pi under root L by G. So this was the drawback of this dimension things. We can't find these constant values, but 90% formula we can get. See, 2 pi only we are not getting. We are not getting the constant values, but all other things we are getting. How length depends upon T, how gravity depends upon T. Correct? So this way we can formulate T. Correct? Okay. Next important topic is rounding off. See, rounding off. Now simple rules. First, like suppose we have 5.64 and another number I am taking 7.64 and this is 7. Suppose 6.9. You see the last digit. You see the last digit. This is 4, this is 9. If it is less than 4, if it is less than 4, then the previous digit will remain the 7. Means if you have to write the round off, it will be 7.6 only. If it is less than 5, again I am saying, if the last digit is less than 5, then the previous digit will remain the same. But if the last digit is more than 5, then the previous digit will increase by 1. 7.7 this will become. Correct? Very easy. Now the problem comes, what if the last digit is exactly 5? Like this. Another example I am taking like this. Okay. What if the last digit is exactly 5? Now, if the last digit is exactly 5 and the previous digit is even, we love even numbers. Remember, we love even numbers. So, the previous digit is already even. So, we are not going to change. So, this will be 7.6 only. But if the previous digit is odd, 3 is odd, but we love even numbers, so we will increase by 1. So this will become 7.4. We will increase by 1 and this will become 7.4. So this is all about rounding off. Next is significant figures. See, insignificant figures, always remember 2 points. Any zero, any kind of zero, at the beginning, if you see, don't count in significant figures. Don't count them in significant figures. I will give example. And if zeros are at end of non-decimal number, see I am highlighting non-decimal number. Non-decimal means 28, 46, which does not involve decimal. Non-decimal number, then don't count. In all other cases, you can count. For example, I am giving like first case. Like if you see 00205, they ask what is the number of significant figures. So these zeros are at the beginning, don't count. So here we have 3 significant figures. If you get 0.00780, so you have again zeros at the beginning, don't count. So again significant figures 3. Correct. Second point, if zeros at the end of non-decimal number, suppose there is non-decimal number, example 125. This is a non-decimal number and zeros are at the end. Don't count. Don't count these. So this will be 3 significant figures. If someone gives like this 4480, how many significant figures? So this is non-decimal number, non-decimal number. So if zeros are at end of non-decimal numbers, don't count. So don't count this. 2 significant figures. Correct. But suppose, for example, someone give 480.05. And they asked how many significant figures here. So tell me, any zero at the beginning? There is no zero at the beginning. No need to think about first point. Zeros are at the end of non-decimal number. Whether this is non-decimal number? No, it is a decimal number. So don't apply this rule. This rule is only for non-decimal number. What I have said, else all other cases count. Else or other, except these 2 cases, all other cases you count. So 1, 2, 3, 4, 5, 6, 6 significant figures. You will say, sir, 0 is at the end. Yes, it is at the end, but of decimal number. This is decimal number. If 0 is at the end of non-decimal number, then don't count. Correct? So this is significant figure rules. Now see, some addition and subtraction. What is the rule? Like for example, I will take one example. 2.0 plus 3.42. You have to add. And they are asking what will be the final result. So first you do normal calculation. Normal calculation means 3.42 plus 2.0, 2.0. So this will be 2, this will be 4, 3 to 5, 5.42. So this will be 5.42. This is the first step. Second step, what the rule tells, that if there is addition or subtraction in the question, we have to see the least decimal place. Least decimal place means here after decimal, how many places are there? 1. Here after decimal, how many places are there? 2. So which is minimum? This is minimum. So your answer should also contain least decimal place, means only one decimal place. So our answer, final answer will be 5.4. After decimal, I am only putting one number. So one decimal. This will be your answer. So always remember, least decimal place, we see this. Now if you have multiplication or division, little bit there is change in rule. Correct? Like for example, 2.0 multiplied by 3.42. If someone asks, so how we are going to do? First, you multiply 3.42 multiplied by 2. Directly we can we will write 6.84. Now here what is the rule? Here it says that if you have multiplication or division, you see the least significant figures. Like in this question, 2.0, how many significant figures are there? Now see, this is a non-decimal number. This is a decimal number. This is a decimal number. So you have to count 0. So 1 and 2, 2 significant figures are there. Here, how many significant figures? 1, 2, 3. 3 significant figures are there. So, in your answer should contain least significant figure, means 2. So, here 6.8 will be your answer. See here, only 2 significant figures. So, in case of multiplication or division, we see least significant figure. Least significant figure. Okay. So this is the rule for addition or subtraction. Correct? Now, next is, see, like if you ask me to measure the length of this pen, what is the length of this pen? So I performed the experiment and I told this length is, suppose, 2 centimeter, for example. So you had a doubt, you said, sir, you just again take 2-3 observations. So my observations were 2 centimeter, 3 centimeter, 1 centimeter. Then you ask, okay, you find the mean value. These are the observations. This is my first observation. First, we will write like AI. First observation, 2 centimeter. Second observation, like A1 you can write, A2 you can write. This is second observation, 3 centimeter. And A3, this is my third observation, that is 1 centimeter. If I ask what is mean of your observation, what is the mean average value? So you will say, sir, 2 plus 3 plus 1 divided by 3, number of observations. Sum of all the observations divided by number of observations. So 3 to 5 plus 1, 6, 6 divided by 3, that is 2. This is 2 is the mean value. So first thing is they ask this. Okay. Then they ask absolute error. Absolute error. Absolute error. What is absolute error? Mean value minus your observations. Like if I ask, what is the absolute error in your first observation? What is the absolute error in your first observation? So I will write mean value minus my first observation. Mean value is 2 minus my first observation was 2. So this we are getting 0. If they ask what is the absolute error in your second observation, so again mean value minus my second observation, that is 2 minus 3, we are getting minus 1. What is the absolute error in your third observation? So mean value minus my third observation, that is 2 minus 1, that is 1. Now what you can see, this absolute error can be positive, can be negative, can be 0. So always remember this point. It can be positive, it can be negative or 0. Then third point they ask, mean absolute error. Mean absolute error. What is this? Mean value of mod of all the absolute errors. Means if I take the mod of the absolute errors, means delta A1, this was my absolute error, I will take mod value plus delta A2 plus delta A3 divided by total we had 3 observations. This is called mean absolute error. So our first delta A1 was 0. Second delta A2 was minus 1, but mod means it will become plus 1. And third already it was plus 1 divided by 3. So how much we are getting? 2 by 3. Now always remember, because we have taken the mod values, it can never be negative. Okay. Next is relative error. So relative error is mean absolute error divided by mean value, like 2 by 3 divided by mean value. Mean value we got 2 now. 2 So 2. So it will become 1 by 3. Then we have percentage error. This is nothing but relative error multiplied by 100. So relative error was 1 by 3 multiplied by 100 means 100 by 3%. This will be your answer. Correct? See, there are many kinds of error. Error is when we are doing experiments now, we do different kinds of errors. Like if I ask some student to like measure the length of this pen, they have tilted the pen or they have tilted the instrument. Suppose scale, we are measuring with the help of scale, they have tilted. So there will be error. So these are human errors. Some are errors caused by environment. You wanted to know the like length of this pen, but this environment is too hot, suppose, and suppose length due to this hot temperature, length of this pen increases. So this environment also creates some error. So how we can minimize errors? So if we take n observations, lot of observations, n observations, our errors are reduced by by 1 by n times. So the more you take the observations, the less is the chance of error. So if you take n observations, your errors will be reduced by 1 by n times. Now see, suppose you asked me that, sir, what is the length of this pen? So I will say the length of the pen is 12 centimeter, and since I know there can be error, I told you error can be created by many factors. So I am not confirm about 12 centimeter. So we take, okay, plus minus 1 centimeter you can take. 12 centimeter plus minus 1, it can happen. Okay, means this will not exceed 13 centimeter and this will not be less than 11 centimeter. So we write like this in this manner. So basically we write like this length. How I can write? This length can be written as this length plus minus delta L. We write in this fashion that the total length equals to L plus minus delta L. This delta L is called error in length. Error in length. Suppose we are calculating any area and we are not confirmed. So again we will write area equals to area, some plus minus delta A. So this will be error in area. Error in area. Now there are some rules for addition and subtraction. For addition or subtraction. Now what is the rule? Suppose there is any quantity x which depends upon this L and B, and the formula of x is L plus B. This is the formula for x. There is any quantity whose formula, just you think like that, whose formula is L plus B. We don't have to focus on which is the quantity, but just you remember like any quantity, its formula is L plus B. Now when we are doing the experiment, we can't say exact length. Similarly, we can't say the exact breadth. So this length we can write like this length can be written as length plus minus delta L. Similarly, breadth can be written as breadth plus minus delta breadth. Means we are not exactly confirmed. So they ask that what will the final length, final this x, how we can write final x. So this final x we can write like final x is also equals to x plus minus delta x. Like this L plus minus delta L, B equals to B plus minus delta B. Similarly, x equals to x plus minus delta x. Now how to find this x and how to find this x? So this x will be, this x how we find, this x directly we write because we know x is equals to L plus B. So this x will write L plus B. And delta x, error in x, always remember error is always added. So we will add the error of length plus we will add the error of breadth. Error is always added. So this delta x will become delta L plus delta B. So finally we can write x equals to x, that is L plus B, plus minus error in like plus minus delta x. What is our delta x? Delta L plus delta B. Correct? Just one example I will take. Don't worry. Just wait for some time. Okay. See, like x is given as L minus B. There is a formula like this, x equals to L minus B. Length is given, you are finding the length, and length you are not confirmed, you are writing 5 plus minus 2. Similarly, breadth you are writing 2 plus minus 1, like this. They will ask how we can write about x. So again I told, x you can always write x plus minus delta x. Now this x, how we are going to write? See the formula of x equals to L minus B. So x equals to L minus B. And this delta x error is always added, delta L plus delta B. Don't think that if it is minus we will subtract. No, error is always added. So delta L plus delta B. So finally our x will become L minus B. Length is 5, breadth is 2. 5 minus 2, that is 3, plus minus error of this and error of this will be added, 2 plus 1, 3. So this will be our answer. This will be our answer. Correct? So this is a rule for addition or subtraction. Now see, what is the rule for this multiplication and division? Let's find out what is the rule for multiplication or division. Okay. Multiplication or division. Like suppose there is a formula, x equals to a to the power p, b to the power q, c to the power r, like this. Correct? Now what the rule says, that relative error in x, see this question is of multiplication, see a to the power p multiplied by b to the power q, and I have added division also in the same question. So divided by c to the power r. In one example, you will be able to understand. So, relative error in X. If someone asks what is the relative error in X? Relative error in X. So, what we write? Delta X by X. Someone asks what is the percentage error in X? So, what we will write? Delta X by X into 100. So what they say that if we have any formula like this, then relative error in X, that is delta X by X, is equals to, see the pattern. First we are going to write the power, so P, then relative error in A, delta A by A, plus we will add, in all the cases we are going to add only, error is always added. Again we are going to write the power, that is Q, relative error in B, that is delta B by B, plus, again we will first write the power, that is R, relative error in C, that is delta C by C. This thing you have to remember. Sometimes they ask what is the percentage error in X? Percentage error in X, delta X by X into 100. This is the percentage error in X. So if you are multiplying here 100, so here also you should multiply 100. So you will write P delta A by A into 100 plus Q delta B by B into 100 plus R delta C by C into 100. This is the percentage error in X. This is relative error in X. This is percentage error in X. This is relative error in X. And what is this is? Percentage error in X. One example I will take, don't worry. Last one example and I will end the session. Okay. See. Question they have given, percentage error in length and G for a simple pendulum is 2% and 3% respectively. Respectively does not mean with full respect. No, not that respectively. Respectively means percentage error in length is 2% and percentage error in gravity is 3%. Some students feel that sir is giving respect to the question. No. So percentage error in length is 2%, percentage error in gravity is 3%. They're asking, find percentage error in calculation of time period of pendulum. Calculation of time period of this pendulum. See, whenever you get one question, read question line by line, and whatever things you can write now, that you write. This is the correct approach. Just don't read the entire sentence. Read line by line, and whatever you extract, you write. Like percentage error in length and gravity is 2% and 3%. Means percentage error in length means delta L by L into 100. This is the percentage error in length is 2%, and percentage error delta G by G in gravity is 3%. Find percentage error in the calculation of time period. Means they are asking what will be percentage error in time period will be delta T by T into 100. They are asking this. First question should be clear. If they ask what is the relative error in time period, delta T by T. Percentage error in time period, delta T by T into 100. We know that time period of a pendulum equals to constant L root L means L to the power 1 by 2 divided by root L by G means G to the power 1 by 2. So delta T by T, what we can write? Just now I told, see here we have constant. Constant is a number, fixed number. So a fixed number does not have any error. Number is fixed now, there is no error. 4 is 4, 8 is 8. So constant we ignore. What I told? First write power. So 1 by 2. Then delta L by L. Plus. Again you write power. 1 by 2. We have G. Delta G by G. We can write like this now. Delta T by 2 equals to 1 by 2 delta L by L plus 1 by 2 delta G by G. They asked, they have given these things into 100 into 100. So here you also multiply na into 100. Here you also multiply into 100. Here also you multiply into 100. Now, can I write half? See, I am writing here. I am writing here. You can focus here. I am writing delta T by T into 100 is equals to half delta L by L into 100. Delta L by L into 100 is 2%, 2. So we can write half delta L by L into 100 is 2 plus half, again half, delta G by G into 100. Delta G by G into 100. See, delta G by G into 100 is given 3. So 3. So 2 cancel. 1 plus 3 by 2. 3 by 2 is 1.5 plus 1, that is 2.5. 2.5%. Delta T by T into 100. They were asking percentage error in time period. Relative error is delta T by T. Percentage error is delta T by T into 100. This they were asking. So delta T by T into 100, that is percentage error in time period, we are getting 2.5%. So practice this kind of questions. They are repeatedly asked in the exam. Go through the entire concepts. Hope you enjoyed the lecture. We will meet again with one more lecture. Okay. So all the best and stay tuned. Thank you.